Okay guys, question 3. The graph shows temperature measured at midday in Celsius in Gori over a period of 13 days starting with day 0. Write down the period and range of this function. Okay, so the period is, at the moment, at the beginning, it's at its top and it's on its way down. We can also see that at 12 days in, it's at the top and on its way down. This means that the period is 12 days. Now the range, like the last one, is the top and the bottom value. So the top value being 21, the bottom value being 17. So the range goes from, remember, low to high. 17 bracket, 21 is the range. That's question 1 done. Which of the trigonometric functions, sine, cos or tan, would best model the situation? Now please remember, day 0, in day 0 we're not starting in the middle, we're starting from the top. This would mean cosine is favoured, because cos is at its maximum value at 0. So the determinant factor is cos 0 equals 1, sine 0 equals 0. The middle of it is here. And we can see that we're very much starting on top of the amplitude. This means that cosine is the best choice for the function we should use. If we're starting from the middle, sine would be the better function to use, but we're not, so it doesn't matter. Okay? Using the graph, find the numbers of days for which the midday temperature was less than 19.5. So what we're going to do here is we're going to graph out 19.5 and move it directly across Simon. Okay? So 19.5 around here. Then bring it all the way across and bring it down. So count the number of dots underneath this. 1, 2, 3, 4, 5, 6, 7. 7 days are underneath 19.5. 7 days. Huh? Yeah, so far. Okay. Number 15. Caroline is suspended in a bouncer 25 centimeters above the ground. She bounces up and down. The formula is B equals 10 sine 45 multiplied by T. Her bouncing height models her bouncing height. B is measured in centimeters and T represents tenths of seconds. So guys, at the moment what happens is, okay, if you take her feet are 25, her feet are 25, so what's that word, 25 centimeters above the ground, okay, so it's 25 centimeters above the ground. Now what happens is, see this 10, this means that she's going to go up 10 and down 10. So it's basically, the movement's going to be like that, a sine function, up and down, up and down, up and down. Okay? When the baby is bouncing, what is the maximum height and the minimum height should be above the floor? Well, it'll be 25 plus 10 is 35 for the maximum. 25 minus 10, which is 15 for the minimum. Okay? Should be above the floor. Okay guys, next one. Draw the graph for the duration of 2 seconds starting with t equals 0. So what we'd do here is we would get the calculator out. We'd go to table mode. Oh sorry, that's not it. Table mode. And then we'd get 10 sine bracket 45. Now we don't use t, we use x, okay? So 45x is what we're using instead. Let's start at 0. Now remember, the variable is time. So she wants us to do 2 seconds, okay? Now, before I do this, look at this answer here. It has 20 down. That's wrong. It's meant to be 2 seconds. So obviously they want us to go up in intervals of 0.1. I wouldn't have known that had I not looked at the back of the book, to be honest, okay? So what we're going to do is, we're going to say it ends at 2, which is your 2 seconds. Our step is going to be 0.1 of a second, okay? Now, if you look at this, okay, each one of these, 1, 2, 3, 4, 5, 6, they don't mean 6, they mean 0.6. So 6 equals 0.6 of a second.
It says on the question, it's tenths of seconds.
Does it say that? Okay. Oh, sorry. T represents tenths of seconds. So, guys, in that part, then tenths of seconds. Okay. That means that 20 is correct. 20 multiplied by 0.1 is 2 seconds. So the number on the x-axis represents tenths of seconds. Okay. So we put it into the calculator, and what we draw here is this is 1, and we have 0.78, which is up here. 0.2. You're talking about 1.56. Oh, sorry, just give me a second. 0.2. And where is 0.6 should be the 4.5. So look, something's gone wrong with that one. Okay, so let me have a look at this again. 10 sine 45x. Okay, so 10 sine 45x, which is the correct amount. Starting at 0. And at 20. Let's do what they did, okay? Step of 1, insufficient memory, okay? So that means that me going up in a step of 0.1 wasn't good enough, so go up in step of 1. Now let's have a look at this. Now it matches it, okay? So now it matches the graph. Okay, so where 10 has to be the amplitude, doesn't it? So 10 up at 2, and then for number 6 it should be minus 10, which is down here, and then you're just plotting your graph. So everybody knows how to plot the graph, right? Okay, so moving on from here, what we're going to say next is what is the draw the time. We've just after doing that there, it's drawn below. What is the period of the function? The period of the function will be from here to here, which is 8 seconds. It's 8 units, but remember it's 8 tenths of a second, so it's going to be 0.8. Yeah, because each gap represents a tenth of a second. It's 8 gaps from
1 second.
No, 2 to 10, peak to peak.
Oh, I see 2 to 10.
2 to 10, and it's going to get me 0.8. Okay. Now, 0.8 of a second. What vertical distance would the baby have travelled during these 2 seconds? Now, vertical distance is in total. So let's see what happens to the baby. She starts off at 0. She goes up 10, down 20. Up another 20, down another 20. Up 20, down 10. Do you understand why it's down 20? From 10 all the way down to minus 10. So it's going to be 30, 50, 70, 90, 100. She's going to travel 100 centimeters bouncing up and down. Or alternatively, 1 meter. If Caroline giggles happily when she changes direction, how many times will she giggle during the 2 seconds? Okay. Okay, so what happens here is she changes direction. She's going up, now she's going down. 1. Going down, now going up. 2. Going up, going down. 3. Going down, followed by going up. 4. Going up, by followed going down. 5. She giggles 5 times during the 2 seconds. One very happy baby. Now, 5 times. Shh, yeah, no, shh. Guys, shh, 5 times, okay? Excuse me. Next one. Now, some parents prefer a bouncer which bounce less often. Write a formula which would maintain the range but produce 1 less giggle. Okay? Now the problem is, at the moment, we have, guys, we have 1, 2, 3, 4, 5. We have 5 peaks, so to speak, okay? Now, remember what I told you the other day. If I want to lengthen it out, what do I do? Or sorry, if I want to... I'm just going to show you a quick example from the last day that will help me explain this question here, okay? So, what I'm going to show you here is an example of a graph called y equals, was it sin x or cos x? Was it sin x, yeah? So here's a graph of y equals 10 sin x, okay? Now what we can see from 10 sine x, and we need to zoom out, actually quite a decent amount. Okay guys, so we can see from y equals 10 sine x that it has a period of 10, but we can see that the gap in the range. Now what happens when we double the angle? What happens when we double the angle? Can anybody remember? Now you're going to be quite surprised. Oh sorry, double the angle. So, okay guys, we can actually see she bounces more often. So increasing the number in front of the t isn't going to work. We're going to have to reduce the number in front of the t. Now we're given a certain way of doing this. This model here with 45 degrees. 45 degrees produces 5 bounces. Divide by 5, every 9 degrees produces 1 bounce. And if we want 4 bounces, we're going to go for 36 degrees. So the answer for this is, find a formula. So the formula will be, they want the range to be the same, which means that they want the 10 is unchanged. Okay, so 10, the formula is B equals 10 sine 36 degrees times t, or 36t degrees. Okay, so we put the degree sign up here. Okay, 36t degrees. So we got that one right. Now the last one is, why would this formula B equals 10 plus m sine 45t, where m is 0, 1, 2, which is months from now. So she's currently, what age is she currently? Doesn't actually give her age. Okay, so let's assume she's a toddler. Let's say 8 months, not walking yet really, so 8 months. Okay, let's say 8 months. Now guys, she's 8 months old, and what's happening at the moment is she's bouncing 5 changes of directions in 2 seconds, and she's gone from 10 centimeters down to minus 10, back up to 10 again. Okay, now what the problem here is, she's currently 8 months old, and let's say she's going to be here for another, I don't know, let's call it 4 months. Okay, now what's the problem with this formula? What happens if I put the number 4 in here? What's going to happen? She's going to be going up 14 centimeters and down 14 centimeters. So it might come to the point where she's actually getting ill because she's going up and down too much. So that's basically our argument. At what point does the model suggest a safety issue? Well, it might suggest a safety issue maybe 4 or 5 months from now, where there's a significant increase in how far and how low she's going, and this may cause upset in the baby. Right, so that's the problem. Another point that could be made is, well, when the number of months, when m equals 15, the amplitude is going to be 25. That means the baby hits the floor. But I would argue is, how long are you going to keep a toddler in a bouncer? Okay, so you might not make the 15 months. So both arguments are worth full marks. Okay guys, question 7. 3 tones of a musical instrument are shown in the diagram on the diagram. Okay, 3 tones have been recorded and their sound waves shown on a diagram. Estimate the period and range of each sound wave given the period in milliseconds. Now, I'm going to do the easy ones first. The answer for wave 2, which is in dotted red, is basically there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each gap is worth 0.1 of a second, or milliseconds wise. Remember, milli means 1,000. Do you understand? So there's 1,000 milliseconds in 1 second. Okay, so 0.1 is worth 100 milliseconds. So each one is worth 100 milliseconds. Okay, so each gap is worth 100 milliseconds, or 0.1 of a second. Now, number 2 has a period of, it's on its way up, and now it's on its way up again. It's 2 of them, so it's going to be 200 milliseconds is the period. Okay, for number 3, or wave 3, it's going to be 1, 2. It's going to be 400 milliseconds. Okay, And for wave number 1 is much more difficult, and I'm going to show you why wave number 1 is much more difficult. It isn't like the last day where we could count the peaks and troughs. It's sort of in the middle, and you're taking a sort of an estimate of when does it starts here, and then the next time it comes up is here, and I have to estimate this distance here. Now what I do in a test, and I'm very fond of using my ruler in situations like this. Okay, so I'd come out with the ruler, and I'm just gonna, because I have sort of adjustable ruler, I'm just gonna make it easy for convenience sake. Okay, so I'm gonna make this worth 2 centimeters. Okay. Now, nearly 2 centimeters. I'm just sort of running out of space a little bit there. Okay, so let's have a look now. Now we can see that it's worth roughly 2 centimeters on the money there. Okay. Now 2 centimeters is worth 200 milliseconds. Everybody happy with that? It's a gap of 2. Now I'm going to read off my ruler. I think I'm looking at 12.5 roughly. I made that one a bit big. You can see there it occurs between 12 and 13 on the dot. So what I have is I have 1.25 centimeters. And what I can do is divide by 2, multiply by 1.25, and I'll find out it's 125 milliseconds. So the period of that one. Are you on? Okay, guys. Shh. The other thing you can do is, you can say that in this question, the wave occurs 1, 2, 3, 4, 5, 6, 7, 8. That's 8 times it repeats itself, which would be a second divided by 8, which is 1.25 seconds, and then convert that into milliseconds, you get 125. Both methods are good. See, sometimes I get confused with the troughs, and I don't think they line up properly, because you can see that the question wasn't finished, so that's why I did it my way. Okay, both methods are fully acceptable. Now guys, next thing, write down the range of each one. Well, the range of number 1, anybody? Range goes from +1 to -1. So -1 to +1. Range of the blue one, which is number 3, goes from 0.5 to -0.5. Range of the second one, yeah, -0.75 to +0.75. Okay, next one. Find the amplitude and frequency of each wave. So what's the amplitude is what, guys? Amplitude is defined as your distance from your middle point. So this black line represents the middle point. So you go for wave 1, we go 1 above and 1 below. So the amplitude is 1. On the second one, number 3, we go 0.5 above, 0.5 below. And then on the last one, it's 0.75. So that's the amplitude. Now guys, frequency is an interesting one, okay? Frequency has 2 definitions, okay? Frequency is equal to 1 divided by the period. And the period has to be in seconds. So what we can do is we can divide 1 by each period in seconds. Now remember, the period in seconds is going to be 0.2, 0.4 and what's that one? 0.2, 0.4. What's the other one?
0.125.
0.125. Divide that in. Divide it by 1. 1 divided by the period, and you'll get that this one is 5. This one here is going to be 2.5. And then the other one is going to be 8. Now guys, there's another way of measuring this. Okay? The other way of measuring it is counting. This one here has 8 peaks. That's grand. The second one has 1, 2, what was it, 2.5, 3, and then the half part here. Okay? So 2.5. I personally prefer the formula because I actually find that quite tough to figure out. So number 2 is meant to be 5. 1, 2, 3, 4, 5. Works out for number 2 well enough, but doesn't really work out for number 3. Unless we count from the start, which might be this here. There's 1. There's 2. There's 3. And that's... So this is the first wave is in between here and here. That's wave 1. Wave 2 is in between 2 and 3. And the third wave, or half a wave, is in between 3 and 4. So it's 2.5. Lads, stick to the formula. Frequency equals 1 divided by period in seconds. Works much better. Okay. Now we're on question 8. Question 8 is the toughest question in the full exercise. Okay. I'm actually just going to take out. What's going to happen here, guys? Excuse me. The diagram shows a Ferris wheel with center 0 and radius 24 meters. Initially, seat A is at ground level. The next seat B is up anti-clockwise at an angle pi over 6. Pi over 6 is what, guys? 30 degrees. How many seats are on the Ferris wheel? Well, the full wheel will have all the points will be equally spaced out at 30 degrees. So 360 divided by 30 degrees gives us 12 seats. So there's 12 seats on this Ferris wheel. Okay? Now, next thing it wants me to do is wants me to find out the arc of Aob. Arc is from here to here. And there's a formula for that. L equals R theta. And theta has to be in what, guys? Has to be in radians. So L equals 24 times pi over 6, which gets us 4 pi. 4 pi meters. Okay, next thing. Find the area of the sector. There's a formula for the area of the sector formula as well. It's a half R squared theta. You would have done it earlier. Okay? And then a half R squared theta will get us a half 24 squared times pi over 6. What's that turn out to be? Is it 48 pi, is it? Anybody? Is it 48 pi? Calculator? Nobody knows? 48 pi. Okay. 48 pi meters squared. Now that that's done, what we're going to be doing next is the wheel turns clockwise through an angle of 2 pi over 3. And once again, 2 pi over 3, multiply that by 180. And you learn that it's 120 degrees it rotates. So it rotates from here, the starting position here, and it rotates up 220 degrees. Now look at this diagram here. You're currently at this point here, aren't we? Yeah? Now guys, look at this. You rotate up 120. Now, if you rotate up 120, what angle is this in here? 60. Because it's 180 in a straight angle. You rotate 120 to get here. Now, I'm going to draw this. What I have to find out is, what is its height above the ground. Do you understand? It's going to be 24, because do you see the way the radius is 24? It's 24 plus the height h. Now let's draw out this triangle here. Okay, Connor? We're going to draw out this triangle here. Now, what length is it from the centre to A? Can anybody tell me? 24. What angle is this in here? 60. Let's find out what h is. How do you find out what h is, guys? What function includes 24 is called what? Hypotenuse. H is the adjacent. Cos. Cos 60 equals h over 24. H equals 24 cos 60, which is 12. Okay? How high am I above the ground now, guys? 24 plus 12 gets me 36 meters above the ground. Okay, now let's rub out all that. Okay, and let's read the next question on. Okay, next question on is you're currently 36 degrees off the ground, and you're currently 36 meters off the ground at location A, and then what I want you to do is the wheel turns clockwise again. How many degrees will the wheel turn for the seat A to be half the height above the ground as it was in part D? Now guys, when I get here, how far am I above the ground from here? 24 meters. So I have to go beyond this point, don't I? So I'm going to be down here somewhere. Okay? Oh, sorry, that's not 24. Now, what is half 36, guys? 18. So I'm 18 this way, yeah? Now, look what I can do here. Drawing this triangle again. Except I got to join it vertically down, okay? I have to find out what this height here is, h. Okay? Or, sorry, I know what this height is. What is it? 24 minus 18, which gives me 6. Okay, this is 6. And the length here is 24. Now guys, how do I figure out this angle to the nearest degree? Theta equals 6 over 24. What function should I use? Sine, cos, or tan? It's going to be sine because you know the opposite and the hypotenuse. So sine theta equals 6 over 24. Sine inverse it. Anybody in class? Sine inverse 6 over 24. I think we're looking at 49 hopefully. Is it 49? What is it?
14.
Oh sorry, 14, sorry, excuse me. 14 degrees.
0.47.
It's 0.47, so just round it down to 14 because you need it to the nearest degree. Now guys, back to the top. We know that this here is 14 degrees. We started off where? We started off up here. So what is it from here to here? Anybody? 60. What is it from here to here? 90. Add 60 plus 90 plus 14 and we should get 164. 164 degrees. Okay guys, next thing. The height h of the seat C above the ground after t seconds can be modelled by the function h of t equals 24 minus 24 cos pi over 6t. Find the initial height of the seat. Now lads, this is like a function question. Initial height means what? When time hasn't started. This means that t equals 0. Your height therefore is 24 minus 24 cos pi over 6 times 0, which in fact is minus 24 cos 0. What is cos 0? Cos 0 is what, guys? 1. So 24 minus 24 cos 0 is equal to 0. So h equals 0. This is what we expected. It starts off at ground level. Yeah? Find the time at which the seat A first reaches its highest point. What is its highest point? Its highest point is at the very top. Now guys, the time. Okay? Now look at this. Okay? It has to reach its highest point. Now look at this graph, guys. H of t equals 24 minus 24 pi over 6t. What happens for the... Put this into your calculator. Okay. Now look what happens for a minute. Okay, so table f of x. Now we're going to use sine 60 degrees. We're going to use 30 degrees. Okay. So we're going to do sine 30t instead. So what we're going to do is this. 24 minus 24 cos 30, and then we're going to multiply by x. What did I say is a really good number to have the 15? Okay, you remember that well. Go to 15, go all the way up to 360. Oh, sorry, I did it wrong. Go again. And then a gap of 15, right? Now look at this. Okay, here's our distance above the ground. Okay, so 0, 15 goes to 48, 24. So it keeps cycling around, doesn't it? Now, does it start off as 0? Starts off as 0. Shh. Now, guys, here's the trick question. At what degrees is it that it's sorry, just 1 second, just check this again. Cos 30 x. Okay guys, sorry, just let me explain this now, okay? What's happening is it starts off at its lowest point, it starts going upwards, and then it hits and comes back down again, and then it comes back up again. That's what's happening in the Ferris wheel. You reach the top when you're up here, and then you come back down again slowly. Okay, that's your height above the ground. Now what you guys got to remember is it's got to turn how many degrees to make it up there? 180 degrees. And this here is 30t. Okay? So how many? It's basically... Okay, so what's basically asking is this equation models it, okay? And what you want is for you to be at the maximum height, you would like this here to be 0. And that's cos. So you'd like that to be 0. Do you understand? Because you're not reducing the height if that's 0. So what you can do is this. You can put this equals 0. So you can put 24 cos pi over 6 t equals 0. The 24 cancels. What you're going to do next is you're going to cos inverse. Pi over 6t equals cos inverse 0. Now when is cos 0, lads, according to your tables? Cos inverse 0. Cos inverse 0 occurs at 90 degrees. 90 degrees is pi over 2. Pi over 6t must equal pi over 2. The pi's cancel. The 6 goes up. T equals 6 over 2. T equals 3 seconds. 3 seconds into your motion, you should be at... 3 seconds into your motion, you should be at the top. Alright? Alright guys.